In this video, we are going to take a look at dilution solution. Please read the OER textbook chapter section 11.6 for more detail. So I'm going to use coffee as an example so that way it's easier for you to understand. Okay, so for example, if you have too strong of a coffee, what do you do, right? So one might say all you need to do is just add water to it. So that might actually make the coffee taste bad, right? Or the other person might say like, well, better way is add milk, right? So that's probably tastes better, that's for sure. So either way, right, whether you're adding water or adding milk, right, you are ending up diluting your coffee, right? So the same way here, right? So when you have the concentrate solution, if you add more of water, which is solvent, you are going to end up to dilute that solution, right? This concentration is going to be more diluted at the end. Okay, so in this case, what you are going to observe if the solution contain color is going to be the difference in color between concentrate solution and dilute solution. Okay, so concentrate solution is going to be darker than the dilute solution. Okay, so the reason for that is because concentrate solution is able to absorb more light, therefore it's going to appear darker color than the dilute solution. However, if the solution doesn't contain any color, then you are not going to see the color difference between the concentrate versus the dilute solution. The next thing we are going to take a look at is going to be the number of solute molecule, right, at the concentrate solution versus the diluted solution. Okay, so let's use the same scenario, which is coffee, right? So if you have concentrate coffee, you add water to it, right, and then it's become diluted coffee. So my question is, did you change any number of solute molecules at all? Or in this case, did you change any coffee molecule at all? Did you add more coffee to this? The answer is no, right? So all you do is you're adding more water to it, right? So that means in this case, the number of molecules or mole of solute will remain the same throughout the dilution process, right? Because you're not changing the solute. The amount of solute in here is remain the same throughout the whole process. The only thing you change is the amount of the solvent. Okay. So, and as you add more solvent, you make the amount of solution to be more, right? So in this case, what change would be the volume of the solvent and the volume of the final solution. But what remained the same would be the amount of solute that remained the same. So the take-home message of this slide would be when you are doing dilution, you are increasing the amount of solvent, right? You are increasing the amount of solution, okay? But the amount of solute remain the same. Okay, so that's the take-home message of this. So the next thing we are going to do is that we are going to relate the amount of solute with the concentration of the solution. As we see previously, right, so the concentrate solution and the dilute solution contain the same amount of mole of solute. Therefore, in this case, we know that both of them contain the same amount of solute. Recall from the previous video, right, we learned about molar concentration, big M, right, is equal to mole of solute, okay, over liter of the solution. The next thing I'm going to do is that I'm going to rearrange this equation so that molar is with the liter, and this is going to equal to mole of the solute. Okay, so if you do this, we know that the liter is express the volume, right? So this means that you can also write as molar concentration times volume equal to mole of solute as well. Okay, so that means in this case, because we have mole of solute here, we can also replace this mole of solute with the concentration times volume as well, right? So as is derived from here. Okay, so that means in this case, if I want to relate this with the concentration unit, right? So we know that molar times volume is going to equal to mole. Okay, so this is of the concentrate one. Okay, so and because the mole are the same, whether it's diluted solution or concentrate solution, therefore we can also say this mole is also equal to the concentration and the times. What does it mean then? Well, because these two are equal, right? So that means we can actually make them as M1V1 equal to M2V2. So this is going to describe two conditions, right? So you have the concentrated solution versus the diluted solution. And as you see, right, so these two, because they are equal, so they are going to constrain by the constant mole, because mole doesn't change. And you will see that this equation right here is going to be constrained by the amount of mole, right? So that means in this case, if you have a high concentration, you are going to end up with a smaller volume. If you want to dilute that solution, you are going to increase the volume, and then you are going to eventually reduce or decrease the concentration of the solution, right? So these two are going to adjust in such a way that is going to eventually equal to the number of mole of solute. So again, this equation right here, M1 times V1 equal to M2 times V2, is only applied when the number of mole of solute stay constant. If the number of mole of solute are not the same, then you are not able to use this M1 V1 equal to M2 V2. Now let's take a look at example 4. Okay, so it's asking us to calculate volume. Okay, so it's giving us the initial volume and the initial concentration, and also it's giving us final concentration of calcium chloride solution. Okay, so it's asking to find out the final volume in this case. So because it's involved with dilution, so we know that the number of mole will not change. So I'm going to use M1 V1 equal to M2 V2. Okay, so I'm going to plug everything in and then solve for V2. Okay, so V2 would come out to be 667 milliliter. You might ask me, hey, wait a second. I thought that molar is involved with mole per liter. So don't we need to convert these to liter first? The answer is no, you don't have to. Okay, so as long as both sides, the volume contain the same unit, you do not need to change that to liter. So in this case, it's asking you in milliliter. We already have milliliter, so you can just plug that in right away. Okay, so your answer should come out to be milliliter. Okay, if you change this to liter, then your final answer would come out to be liter, and then you have to convert back again to milliliter. All right, let's take a look at number 5. Okay, so in this case, I want you to pause video real quick and then complete this number 5 real quick. Okay, so after you finish, then resume the video again. Now let's check your work together. Okay, so this problem asking to find out how much water that need to be added, right, in milliliter, is giving us the initial concentration, is giving us final volume, and also final concentration. In this case, we pretty much going to find out V1. Next, all you need to do is plug in all this value into the equation of M1 V1 equal to M2 V2. Okay, so because the volume is in liter or given in liter, so therefore when you calculate for this, your volume is going to come out in liter as well. Okay, so but the problem asking for milliliter, so you need to do one more step, which is going to convert that liter into milliliter. This answer is not your final answer because the problem asking you for how much water is need to be added. So what you need to do is going to be calculated for the added water by subtracting 525 milliliter, which is the final volume, right? By 105 milliliter, which is the initial volume. And the difference of that is going to be the amount of water that you need to add to the initial solution. All right, so the last example is number 6. Okay, so I would like you to pause the video and then complete this example and then resume the video again when you finish. Now let's check your work together. So in this case, it involved with dilution problem again, right? So we are going to use M1 V1 equal to M2 V2 again. Okay, so if you set this up, you are going to have to solve for the final concentration M2. Okay, so again, as long as the volume are the same unit, you don't need to change those, right? Because eventually these two are going to cancel out anyways. So you are going to get the final molarity equal to 2.4 molar. Okay, so if your answer is 2.4 molar, this is incorrect. Okay, so the reason for that is because we are adding 155 milliliter of milk to the solution. So that means in this case, your final volume is not going to be 155. It is going to actually be 155 add to the 250 milliliter, which is the initial volume. So if you correct this, you are going to actually get the molar concentration equal to 0.93 molar. Okay, so which is makes sense because remember, if you dilute something, your concentration or your final concentration have to be lower than the initial concentration, right? So that's make more sense to have a lower number than the higher number that we calculated earlier. Okay, so in this case, read the problem carefully. Whether is added to or is already total volume. In this video, we look at dilution solution and we apply the M1 V1 equal to M2 V2 in our calculation. Please start working on your homework 11.3